Hey guys, so in this video we are going to do our first part of our review on finding solutions to a quadratic. And the first thing I want us to do is to recall the different ways that this could be asked if you're asked to solve a quadratic or find the solution. There's a few different terms that they could use, and I want to make sure that we remember that. You could be asked to find the solutions. You could be asked to simply solve the quadratic. But they could also ask you to find the zeros. Or you could be asked to find the roots. And any of these terms can be used, and they're asking you to do the same thing. Now, when we were solving quadratics, finding their solutions, their zeros, their roots, we've done this multiple ways in our quadratics unit. We have solved by graphing, using a table, factoring, using the quadratic formula, and by completing the square. And what I want us to do is I want us to review the two ways that we talked about will work no matter what. And those two methods are by using the quadratic formula and by completing the square. And in this video, we are going to focus on solving using the quadratic formula. Now, hopefully immediately the song that we learned the quadratic formula to popped into your head and you're able to write this down, because the thing is using the quadratic formula, it only works if you know the formula correctly. And so let's see if we can write that down. We've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And all this comes from a quadratic being written in standard form, which is that ax squared plus bx plus c. As long as the quadratic is written in this form, and if it's already written as an equation, it has to be equal to 0, then we can solve using that quadratic formula. So let's go ahead and see an example here. Example 1. Let's do 2x squared plus 5x equals 7. Again, this is a quadratic already written as an equation, and we know it has to equal 0 before we can solve. So we have to subtract this 7 before I can do anything, or I will not correctly identify a, b, and c. So we have 2x squared plus 5x minus 7 equals 0. And here we can see that a is 2, b is 5, c is negative 7. And at this point, it's simply plugging into the formula and simplifying. And that simplifying part is where we can maybe make some of those mistakes that we want to try to avoid. Okay, so let's fill this in. X equals negative b, so we're going to have negative 5 plus or minus the square root of 5 squared minus 4 times 2, which is a, times negative 7, which is c, all over, that includes this negative 5 over here, all over 2 times 2. All right, and so now we just need to simplify here, okay? We've got negative 5 plus or minus the square root. We got 25, which is 5 squared, minus 4 times 2 times negative 7. I believe that will give us, let's see, 56. Then all over 4. So we have negative 5 plus or minus the square root of 81 all over 4. Once we get to this step, we need to look at this radical because we really need to try and simplify that. And our first question, like if we were just simplifying a radical, if we weren't actually trying to solve an equation at the same time, is we would ask ourselves, is this a perfect square? And if not, then we would try to simplify the radical from there. Okay, but 81, it is a perfect square. So let's just take the square root of 81. We get negative 5 plus or minus square root of 81 is 9 all over 4. And we cannot leave it like this. We can solve for those two answers. So what we have is we have these two cases here. We have two x values. Negative 5 plus 9 all over 4 and negative 5 minus 9 all over 4. So here if we simplify, 4 over 4 is 1. And negative 14 over 4, that gives us negative 7 halves. And these are our two solutions, or zeros, or roots. Either of those terms can be used to identify what these x values are. All right, so let's do another example though. What about if we don't end up with that perfect square? That worked out well for us this time. So let's do example 2. All right, and for example 2, let's do 2x squared minus 2x minus 3. And again, you could be asked to find the roots, find the zeros, find the solutions, or solve the quadratic. And here we have a is 2, b being negative 2, and c being negative 3 because it was already equal to 0. We didn't have to worry about that part. All right, and let's just plug it in. Negative b is actually going to be positive 2 plus or minus the square root of negative 2 squared minus 4 times 2 times negative 3 all over 2 times a, which is 2. All right, so we got 2 plus or minus. I want to show these steps here again because remember, negative 2 squared is positive 4. And then negative 4 times 2 times negative 3, that should get us 24. So we got 4 plus 24 all over 4. So we've got 2 plus or minus the square root of 28 all over 4. Remember, at this point, we look at the radical. We need to simplify that. And if we were to try and simplify the square root of 28, we want to think of 28 isn't a perfect square, so we want to think of a perfect square that goes into 28. And so I'm going to come over here to the side just so I don't have to rewrite the whole thing. Maybe I'll do it in a different color so it doesn't mess us up here. So if we have the square root of 28, let's see, 4 goes into 28, so let's split that up. Split that 28 up with the square root of 4 times the square root of 7, because 4 times 7 will give us that 28. And that gives us 2, square root of 4 is 2, the square root of 7. So this is going to replace the square root of 28 in the problem. All right, so we get 2 plus or minus 2 square root of 7 all over 4. And at this point, there are a couple ways that you could write your final answer, but the thing is we still have to simplify this fraction. You could split it up into 2 fractions. 2 over 4 plus or minus 2 square root of 7 over 4. But we typically leave it like this, and what we do is we have to look at every single term to simplify. And the nice thing that we can do whenever we have this fraction is think about a triangle. Think about the 3 corners of a triangle. Notice that the square root of 7 is not part of that. We're looking at 2, 2, and 4. What is the largest number that goes into those 3 numbers? And that's 2. And so we divide each one of them by 2 to simplify. That's how we can simplify this fraction. So 2 goes into 2 once, plus or minus 2 goes into 2 once. We leave the square root of 7 alone. 2 goes into 4 twice. And really, we don't need this 1 in front of that square root of 7. So the way you'll see this written is 1 plus or minus the square root of 7 all over 2. And that would be our solutions, our zeros, or our roots. Okay, and now I want y'all to do one. So let's have an example 3 here. This is the one I'm going to give y'all a few minutes to start on, and then I'll be working on it too. We'll do x squared minus 4x plus 1 equals 0. All right, we want to find the roots to this quadratic. I'm going to give y'all a few seconds to get started, and then I'll begin working on it as well. Alright, so at this point, let's talk about what I have so far. I've identified a, b, and c. It was already equal to 0. I've plugged in those values, made sure that when I squared the -4, I got 16. And down here, we should all at least be at this point where we have 4 plus or minus the square root of 12 all over 2. And here is where we want to simplify the square root of 12. 12 is not a perfect square, but there is a perfect square that goes into it, so we can take this solution a little bit further. So if we think about the square root of 12, we can split that up to the square root of 4 times the square root of 3, which is then 2 square root of 3. So that's what we're going to replace the square root of 12 with. And then see if maybe this fraction can be simplified. So we get 4 plus or minus 2 square root of 3 all over 2. Let's think about that triangle. Can I simplify those three values? And I can. 2 goes into all three, so I end up with 2 plus or minus 1, because 2 goes into 2 once. Leave that square root of 3 alone. I can't do anything with it. 2 goes into 2 once. Remember, we don't need to have this 1 down here in our denominator, and we don't need to have it out in front of the radical. So really, our answer will be seen as 2 plus or minus the square root of 3. These are our solutions, our zeros, our roots. And another just reminder, remember the commutative property. We can write this either way, just make sure that you leave the plus or minus with the radical. You could even see it maybe written as plus or minus the square root of 3 plus 2. You never know what you could see, and so we need to make sure that we remember that these are the exact same thing. But this is solving quadratics using that quadratic formula.